All right, guys, I'm gonna go over the homework from last night. All right, so for the first one, Andrea is a very good student. The probability that she studies and passes her math test is 17 out of 20. So like I did in the notes, I know that the and statements are important. So she studies and passes her mathematics test is a 17 out of 20. Now, yesterday it was either probabilities or it was percentages. You can still find a probability from 17 out of 20. You just put in your calculator and you get a decimal, okay? So the probability that she studies and passes her math test is 17 out of 20. If the probability that Andrea studies is 15 over 16, find the probability that she passes her math test. Okay, so find the probability that she passes her math test given that she studies. So the key word here is given. Okay, so remember our formula. Okay, so we're gonna do probability. We are gonna do probability that she, let's see, she wants, so she passes her math test, so pass, given that she studied. So that's what I'm asking you for. So the probability that she passes given that she studied, okay? So remember, this formula is the probability of, we can do A and B, okay? The probability of A and B over probability of B. So the probability of that she passes and she studies was 17 out of 20. Okay, now 17 out of 20, 17 divided by 20 in your calculator is 0.85. Okay, and the probability that she studies is 15 over 16, which is 0.9375. So let's round this to, let's just do 0.9375, sorry. So 0.9375. So now you can plug that in the calculator and you will get 0.85 divided by 0.9375. So 0.90 or 0.91 if I round. Okay, so 0.91. Now, I'm asking you for probability here. Okay, so this is my answer. If I asked you for percent, I would say 91%. Okay, the second one. The probability that Janice smokes, let me see. The probability that Janice smokes is 3 out of 10. The probability that she smokes and develops lung cancer. So smokes is 3 out of 10. Smokes and develops lung cancer is 4 out of 5. Or sorry, 14 out of 15. 4 out of 15. And our question says, find the probability that Janice develops lung cancer given that she smokes. Okay, so I'm going to set this up the same way. So the probability that she has lung cancer given that she smokes. So all I did was I wrote my sentence as probability statement, okay? That formula is probability of A and B over probability of B. Okay, so probability that she has lung cancer and she smokes, so my numerator is 4 out of 15. So 4 divided by 15 is about 0.27. I would round to the nearest 2 decimal places, okay? Even though we didn't do that in number 1, your answers are still going to be about the same, okay? And then probability of B, so probability of B is that she smokes. So the probability that she smokes is 3 out of 10, which is 0.3. Okay, So 0.27 divided by 0.3 equals 0.9. Okay, so there's your answer. Okay, next one. All right, probability that Sue will go to Mexico in the winter and to France in the summer is 0.40. So 0.40, sorry, it's hard to see. So Mexico and to France is 0.40. The probability that she will go to Mexico in the winter is 0.60. So Mexico is 6.60. Find the probability that she will go to France this summer given that she just returned from the winter with her winter vacation in Mexico. Okay. All right, so again, probability. I'm going to rewrite my question as a probability statement. So probability that she will go to France given that she just returned from Mexico. Okay, so France is my A, Mexico is my B. So probability of France and Mexico divided by probability of Mexico. Okay, so I wrote it in terms of F and M. You can still do A and B if you want to. So this could be A, this could be B, this could be B. Okay. Sometimes I just like to do letters that represent the problem to make it a little bit easier to know. Okay. All right. So probability that she goes to France and Mexico is 0.40 over probability that she just goes to Mexico is 0.60. So 0.4 divided by 0.6 is 0.666666. So we could say about 0.67. And again, I'm asking for probability, so that is my answer. Okay, the next one. A penny and a nickel are tossed. Find the probability that the penny shows heads given that the nickel shows heads. Okay, all right, so we need probability. So find the probability that the penny shows heads given that the nickel shows heads. Okay, so probability of heads and heads divided by probability of heads. Okay, so this one's a little bit different, okay, because we have two coins. So when we have a nickel, you can either have heads or you can have tails. If you have a penny, you can either have heads or you can have tails, okay? So the probability of you landing, so there are 4 total possibilities here, okay? So the probability of you getting heads and heads would be 2 out of 4, okay? So half over, now probability of you just getting a head is also 0.5. So 0.5 divided by 0.5 is 1. So the answer here is 1. So find the probability that the penny shows heads given that the nickel shows heads is 1. Okay. All right, number 5, penny is tossed. Find the probability that it shows heads. Compare this answer to number 4 and explain the results. So here I am just talking about a penny. Here I was talking about a penny and a nickel. So a penny is tossed, find the probability that it shows heads. Now, there is no given statement here. So there is no given here. So you're just going to do the probability of getting a heads if you were to toss a penny, okay? So a penny has heads and it has tails. The probability of you getting or landing on heads, okay, which is right here, is 1 out of 2. So this is like what we did before spring break. This is your total over what you're looking for. Okay, so what you're looking for over your total, okay? Just like if you have a spinner, okay, 1 out of 6. What's the probability of you rolling a 2? 1 out of 6, because there's only 1 2 on a dice of 6, okay? So this problem is different from this one because there is no given, okay? There's no conditional probability, and you're not flipping 2 different things, you're just flipping 1 penny. So that's what you could say as number 5 for your explanation. All right, I'm gonna skip number 6 because the spinner is weird. I don't know what it's supposed to look like. I don't know if what it was on there was correct, so we're just gonna skip it in general and go down to number 7. A family that is known to have 2 children is selected at random from amongst all families with 2 children. Find the probability that both children are boys, given that the boy is the boy in the family. Okay, so a family is known to have 2 children, is selected at random from amongst all families who have 2 children. Find the probability that both children are boys, given that there is a boy in the family. It's a tongue twister. Okay, so we need probability. So we need both boys, given that there is a boy in the family. Okay, so 2 children. So we need the probability of boy and boy over probability of boy. Okay, so it says find the probability that both children are boys. So that's where this BB comes from. So find the probability of both are boys, given that there is a boy in the family. Okay, so you're gonna have to do a little side work here. Okay, you can either have a girl and a girl, you can have a boy and a boy, you can have a girl and a boy, or you can have a boy and a girl. Okay, now it doesn't say anything about oldest and youngest and all that, so what I'm going to do is I'm going to get rid of the boy and the girl. Okay, I don't care whether this girl is older than this girl, I don't care if this boy is older than this boy, I don't care if this girl is older than this boy, or vice versa. Okay, it doesn't say about anything about order matters here. Okay, so there are 3 possibilities here with 2 children. Okay, so the probability that both of them are boys, okay, is 1 out of 3. Okay, so 1 out of 3 is 0.33. And probability of getting a boy. Now, probability of getting a boy is 1/2, okay? Or we could say, let's see, find the probability that both children are boys, given that there is a boy in the family. Okay, so let's go back to what we did over here, okay? So we can either have girl, girl, boy, boy, or girl, boy, okay? So we're gonna say the probability of you just having a boy in the family is 2 out of 3. So 0.6, we'll do 0.67. So 0.33 divided by 0.67 is 0.49. Okay. Okay, so let's go ahead to the next one, number 9. A number is selected at random from this set. So you have 1, 2, 3, 4, 5, 6, 7, 8. Find the probability of an odd number. Now, this is just an odd number. I did not say odd number given that whatever or anything like that. Okay, so I'm just finding the probability of an odd number. So this is like where you're gonna do like at the top here where you did what you're looking for over your total. Okay, so I'm gonna do odd numbers. So my odd numbers are 1, 3, 5, 7. So I have 4 odd out of 8 numbers, which is 1/2, or you can say 0.5. Okay, now the next one is different because now it has this little line here. Remember, this line means given. Okay, so now you're going to do your formula. So it says find the probability that your number is prime given that it is odd. Okay, so prime, so this formula is going to be probability of prime and odd over probability of odd. So we're going to look back up here. Okay, so it has to be prime and odd. Now, prime means that they're all divisible by itself and itself and 1. Okay, so 7 it can't be divided by anything. Same with 5, same with 3, same with 1. Okay, so 4 out of 4 is 1 divided by probability that they're odd is 1. So your answer is 1. Okay, because I have, hold on, I did the numerator wrong. Okay, so probability that it's prime and odd is 1, 2, 3, 4. So 4 out of 8. Okay, which is 0.5. Because it's prime and odd. So prime and odd out of this set, they're all prime and they're all odd. So 4 out of 8. Okay, because you're still looking at the whole set, and then the probability that they're odd. So the probability that they're odd is also 4 out of 8, okay, which is 0.5, and that's equal to 1. So that's how you would do it. Okay. Okay. The box contains 3 blue marbles, 5 red marbles, and 4 white marbles. If one marble is drawn at random, find the probability that it's blue, given that it's not white. Okay, so let's see, we have 3 blue. Oops. We have 3 blue. We have 5 red. And we have 4 white marbles. All right, so probability, so remember this right here means given, so we have to do our formula. Okay, so we're gonna say the probability that it is blue and not white over the probability that it's not white. Okay, so probability of blue and not white. So blue is 3, not white is the 5 red, because I'm not saying blue and white. Okay, so the probability of blue and not white, so we're still going to do our total. So we still have 3, 8, we still have 12. So blue and not white, we are going to do 3 and 5 is 8. So that's our numerator, is 8 out of 12. Divided by probability of not white. Okay, so not white is 8 over 12. Now, 8 divided by 12 is 0.67 divided by 0.67, which equals 1. Okay. Now we want to do the next one. It's also a given, so the probability that it is not red and not white over probability that it's not white. So marbles that are not red and not white are the blue ones. So we're going to do 3 over 12 divided by probability of not white is our 5 red and 3 blue is 8 over 12. So 3 let's see, the numerator is 0.67. So 3 over 12 is 0.25. So 0.25 divided by 0.67 is 0.37. So there are your answers for those. Okay, next page. Oops. All right, a number selected at random, or I didn't even see the answers down here, okay? I won't go ahead and do these. You guys have the answers for all of them, but hopefully you have enough explanation, okay? Let me know if you need anything, and I'll be here for you.